17A, question 1E. Jane, think of a number k, and when this number is cubed, the answer is m times k. When this number is squared, it is n more than k plus 5. And give an expression for n in terms of m only. Alright, so for this question, is just interpret the sentence and put that into algebraic expression. So since we already know the number is k, we don't really have to make up a letter. So this number k cubed, we have m times of k. Yeah, just honestly interpret that and write it down. When this number is squared, and that's going to be n more than k plus 5. Yep, so that's k plus 5 there, and that's n more. Okay, so we want to express n in terms of m. So it's going to be n equals to something something m on that side, right? So hence we do not want k to be said. So hence we have to remove somehow the k from the equation. We can see the first equation actually contain m. The second equation contain n. The connection between these two equations is really both equations actually contain k. K's become the connection between these two equations. Alright, so can we actually simplify that? Looks like the second one is really hard to simplify. That's right. The first one seems like, oh, okay, there is a k on both sides. I can probably simplify that. So if I actually simplify the first equation, I should have k cubed and equals to m times k. If I actually divide k to both sides, and that's probably can simplify to something like k squared equals to m. Alright, that's actually helpful. We can at least have k squared equals something, and that's actually contained in the second equation. Alright, so that's sorted. I can actually express it as something of m, right? And what is k going to be? We want to replace this k to m. Can I actually change that k squared equals to m to expression so that k equals to some sort of m? How do we get rid of that square? Okay, reverse that, right? Which is square root, right? So if I actually square root both sides, that one and that one, that's fine. By the way, just to remind you, the square root underneath that number must be positive. Otherwise, we can't explain that, right? But we do understand k squared, something squared is going to be a positive number or 0, right? So hence that's satisfied. So hence I can square root. Okay, that simplifies. So hence square root and take away that square away. And so k is equals to square root of m. Oh, okay, so hence k can be expressed as some sort of m. Pretty good so far. So we just replace that. So we have the first one and we have the second one. Let's actually just substitute this two over there to the equation number 2. Let's have a look what we have. So k squared become m equals to n plus k becomes square root of m, and that plus 5. Okay, almost there. Because we want n in terms of m, so hence n should be by itself on the left hand side, should I say? Or just by itself. So hence we want to remove everything else with the n. How do you remove a plus something? You minus, right? So hence we're going to minus square root of m, and we're going to minus a 5. So that's all gone there. So hence on the left hand side, we should minus the same thing there. Okay, so on the right hand side, n is equals to, on the left hand side is m minus square root of m minus 5, and this one is gone, right? And that's it, and an answer, and that's an excellent question. Let's have a look at the marking so that we understand what's going on. Alright, so if you have one of this, number 1, write down correctly the expression as this, and that's a point of achieved. And if you have consistent expression without k squared, what does it mean is if you actually turn that into this one, right? If we just get rid of that k squared into m, right? So that's also 1 point achieved. And if you actually turn k into square root of m, that's another point of achieved, should I say. If you satisfy one of them, it's achieved point. Now, if you have 3 out of that 4, and that will be a merit point. And of course, if you have final answer over here, that will be excellent. Great. By the way, plus minus is not required. So, great. Thanks so much.